Okay, so today we're going to talk about conditionals and then the related statements. So there's conditionals, and that's a logical statement that's got two parts. It has a hypothesis and it has a conclusion. So a conditional statement is something that's read like this. If P, then Q. If this, then that. All right, and symbolically, it's got a single arrow in between them. So we talk about a conditional statement and it looks like this. If P, then Q. So this has a scenario also. This scenario says, Mom says to you, if it rains in the morning, then I'll drive you to school. But here's the deal. Here's the condition. The condition is if it rains, I'll drive you. Okay, so think about what that means. If it rains, then I will drive you to school. Okay, so let's take our truth table. They always start the same way. TT, TF, FT, FF. So the question is if it, not the question, but the condition is if it rains, I'll drive you. So take a look here. Did it rain in the morning? Well, yes. Did your mom drive you to school? Well, yes. Did she tell you the truth or a lie? Well, she told you the truth, right? So it rained, you got your ride. Let's try this again. Therefore, mom told me the truth. Next time, right? Did it rain in the morning? Yes. Did your mom drive you to school? No. Did she tell you the truth or did she lie to you? Well, she lied to you, right? It rained and you didn't get a ride. You got to school and you're wet and you're angry. Look at the next situation. Did it rain in the morning? No. Well, does it matter what your mom does, right? If it doesn't rain, she has no obligation. The obligation is if it rains, she drives you to school. Well, it didn't rain. She drove you anyway. She never lied to you. She told you the truth because there was no rain. And that's the same thing on this last one. Does it rain in the morning? No. Well, it doesn't matter what she does. She doesn't have to drive you. It didn't rain. In this situation, she didn't drive you. Should you be mad at her? Absolutely not, because it never rained. Let me fix this. Let me get this down here. Okay? So the only time a conditional is false is when it was when it rains and you do not get a ride. So here's how you answer this bottom piece. The only time that a conditional is false is when the hypothesis is true, but the conclusion is false. It's got to rain and you're not going to get a ride for her to have lied to you and for you to be upset. Okay? Let's take a look at the next thing. So now there's these related conditionals. There's the converse, there's the inverse, there's the contrapositive. And they're all based off of this conditional statement. If P, then Q is where everything gets based off of. Well, the converse, what's really nice about the way to memorize these things is the converse, I've got these two letters underlined and in bold. That just means you're going to change the order. So if the conditional starts out if P, then Q, then the converse just changes the order. If Q, then P. Okay, that's all you're going to do. So this final statement would be if Q, then P. Remember, truth tables always start out the same way. TT, TF, FT, FF. So your conditional is still the same, or your converse is still the same scenario. The scenario still is if it rains, do I get a ride to school? But you're going in the reverse order. So now you're looking from from Q to P. So did it rain? This is column 1. This is column 2. Did it rain in the morning? Did you get your ride? Yes, all is well. It doesn't rain in the morning. Doesn't matter what your mom does. She's never lying to you. Did it rain in the morning? Did you get your ride? No, it rained, you didn't get a ride. That's a problem. And then it doesn't rain, you don't get a ride, but that's okay. Okay, remember, the only time that the conditional is going to be false is if it actually rains and you don't get a ride. The inverse. The inverse of the conditional is basically IN or I negate. So what happens here is if the conditional starts out as if P then Q, the inverse says, well, I need to negate my conditional. I negate my P and then I negate my Q. And that's what the inverse of the conditional looks like. So in our truth table, we've got to have columns for P and Q, TT, TF, FT, FF. We have to have columns for the negations. So if I negate all of P, it becomes FFTT. If I negate all of Q, it becomes FTFT. And now my inverse of my conditional is negate P, then negate Q. So this column right here talks about the rain. This column right here talks about the ride. And as I look through it, well, it didn't rain, doesn't matter what happens, I'm never lied to. Didn't rain, doesn't matter what happens, I'm not lied to. It rained. What happens? I didn't get a ride. That's a problem. It rained, I got my ride, all is good. Okay? The last related conditional is something called a contrapositive. The longest word, you do the most things to it. Not only do you change order, how cool is this, right? CON, but you also negate. So what happens now is if my conditional is P then Q, my contrapositive is change order and negate. Okay? Pretty easy. Very easy to memorize this stuff. So let's do this again. Truth table, TT, TF, FT, FF. Negate P. Well, that means all the opposites. So I got to go FFTT, negate Q, FT, FT. And now my contrapositive is this last piece that we just said, which is going to be negate Q, negate P. Well, in this case, when I do this rain and ride situation, I need to make sure that I look at the fact that did it rain? That's this one. That's my first negate Q. And then did I get my ride? Well, let's see. Didn't rain, doesn't matter what happens. Rain, no ride, problem. Didn't rain, doesn't matter what happens. Rained, got my ride. Okay? So these So if you take a look at the final truth values, right, you got to kind of put these all next to each other. But if you look at the final column of the contrapositive, which is TFTT, and then you look at all the other final columns, we're looking for the one that says TFTT. If I go back to my very beginning, it's the same as my conditional. Okay? So what that means, boom, 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 whoops, go back here. So the conditional statement and its contrapositive have the same final truth value. Because of this, they're considered to be logically equivalent. Did I spell it right? EQUIV. Yes, I did. Okay. So here's where we're going to do a couple of things. We're going to write the converse, the inverse, and the contrapositive of the following conditional. And then we're going to determine the truth value of each statement. So if the measure of angle A, you don't even really need to have this thing here. So if angle A equals 99 degrees, then angle A is obtuse. This becomes the original statement, if P then Q. Well, if A is 99 degrees, then of course it's obtuse, right? Because an obtuse angle is an angle that's measures more than 90 but less than 180. The converse for me just says I need to change the order. I need to actually write this sentence. And that sentence would look like this. If angle A is obtuse, then angle A measures 99 degrees. Well, is that true? If I have an obtuse angle, does it have to measure 99 degrees? And that answer should be, well, it could, but it doesn't have to. My inverse, I negate. I'm going to go back to my conditional, and I'm just going to negate the conditional. So if angle A is not 99 degrees, if angle A is not equal to 99 degrees, then angle A is not obtuse. Well, what's the true statement on that? If the angle isn't 99 degrees, then is it not obtuse? Well, that's not true, because couldn't the angle be 100? And then it would be obtuse. So this answer right here, truth value, is a false one as well. Let's go to the last but not least, the contrapositive. That's where not only do you change order, but you also negate. So I need to say, all right, if angle A is not obtuse, then angle A does not equal 99 degrees. Well, think about this. If the angle is not obtuse, then could the angle be 99? And the answer is, well, no. So this is true. Another reason also why this is true is because don't forget, we said on the last slide that whatever the truth value of the conditional is has to be the same truth value of the contrapositive. The conditional and the contrapositive are logically equivalent. Last but not least, write a statement that's logically equivalent to. Well, logically equivalent to means the contrapositive. So if this is if P, then Q, the contrapositive is going to be negate Q, negate P, but it wants you to write the sentence, so that would be if. This says if you prepare for the test, then you cannot fail. So I need to negate this. If you don't prepare for the test, then you can fail. But remember, change the order. So if you fail, then you did not prepare for the test. Okay? So we've got conditionals, we've got related conditionals, which are the converse, the inverse, and the contrapositive. Good luck on your homework.